Hello, welcome to our final project video. Our project is on the Neom city in Saudi Arabia, specifically the line. And if you're not familiar, we're going to play a video to catch you up to speed.
For too long, humanity has existed within dysfunctional and polluted cities that ignore nature. Now, a revolution in civilization is taking place. Imagine a traditional city and consolidating its footprint, designing to protect and enhance nature. The line will be home to 9 million residents and will be built with a footprint of just 34 square kilometers. And we are designing it to provide a healthier, more sustainable quality of life. The line's communities are organized in 3 dimensions. Residents have access to all their daily needs within 5-minute walk neighborhoods. And the line's infrastructure makes it possible to travel end-to-end in 20 minutes with no need for cars, resulting in 0 carbon emissions. By leveraging AI technology, services are autonomous, saving you time and effort. Designed by world-leading architects, the line is 500 meters tall, 200 meters wide, 170 kilometers long, and housed within an elegant mirror glass facade. Intelligent solutions create efficiency and year-round temperate microclimate with natural ventilation. Energy and water supplies are 100% renewable. The line is designed as a series of unique communities, offering a wealth of amenities, providing equitable views and immediate access to the surrounding nature. With 40% of the world accessible within 6 hours, at the heart of the globe's key trade routes, a place for commerce and communities to thrive like nothing on Earth seen before. The line, the city that delivers new wonders for the world.
As you can see, pretty cool. A lot different than what we're used to. But the big thing that we want to analyze for our project is that they promise to be a carbon-free energy city. And our goal is to determine the optimum diversification of their power grid. So the 4 different energy production systems they listed they're going to use is green hydrogen fuel cells, wind, thermal solar, and then photovoltaic solar. So the goals and constraints of our project is 1, we want to maximize efficiency. So to do this, we have 4 boundary conditions for our final function. We're going to have the total energy production should satisfy consumption. Core of the energy must be from the green hydrogen fuel cells. Reason for this is in case of a catastrophe or any anomaly with wind and sun availability that essential services can still be provided. The total area must be greater than the size of the Oxagon, which is an offshore part of the Neom project as a whole, and it's a good minimum area for what our energy should take up. The maximum energy over cost ratio, that goes back to just efficiency. Our approach is we're going to split each of the different systems into a function, and the output will be cost per area as well as energy per area of each system. Then we're going to take our 4 produce functions and use them in our main optimization function. So first off, we have the photovoltaic cell plant. For this function, we use a lot of research from the internet and available radiation maps to determine what efficiency we're going to use, the cost of our panels, and then how much energy is going to be produced out of them. For thermal solar, our goal is to extract data and then use that in the solar model. And we're going to interpolate by the condition. So the expected output of the concentrated solar power plant to be built in Neom was calculated by the following mechanism. Here are our functions we used. Because for the thermal, we also need to take into account the angle of the sun and as well as different angles of the sun and intensity of light and heat throughout the day. The functions we used in terms of the actual project. And here we are using the latitude of the city as well as the yearly times of the city as well, to make sure we have an accurate output of how much energy is going in, and then what our energy output is, as long as the cost, as well as the cost per area. Next, we have the wind power plant. And so our goal here was to multiply our cost per energy produced with the energy of the per area of the wind turbine. So we're establishing the area of each turbine as a unit and how much each unit will produce. Here's the data we used, as well as the first part of the function. We also found the annual wind velocity, which sometimes depend on the month of the year. Then we use that to then plug into the greater function to find the average amount of wind power produced annually. Here we also take into account the air density, as well as the general mechanisms that produce output of the wind turbines. And then from research, we also found what the cost would be of a certain turbine that Neom could purchase. Next, we have green hydrogen energy. And for green hydrogen, our method wasn't too in depth. It's an excellent energy storage system, and it's a great tool for carbon neutrality. Among the various fuel cells, the SOFC was set as the model, and the energy density and price per unit area were calculated, assuming that the most famous model is the Bloom's Energy ES5 server. So that's what we decided to use for our project. First, we set initial conditions such as the area of the Neom city or the annual energy consumption. We then calculate the energy density and the price per unit area of each of the previous calculated eco-friendly energy sources. Our units are watts per meter squared, as well as cost per meter squared, respectively. So to the proper extent, no source is negative. We also found that the total price is increasingly dependent on solar heat available. So here is the tolerance we have, and we wanted that to make a balance with each energy source, and we found it actually distributed quite evenly. Here are our final graphs of number of how many in terms of units, and then we also have the energy produced. We see that the photovoltaic efficiency is overwhelming in terms of efficiency. SOFC makes the largest production, and energy production is close to each other, even though the cost is at a minimum. So with this, we're gonna, from our last graph, recommend these figures to Neom. If you have any questions, please leave them in the comments, and we'll be glad to address them. Thank you very much, and have a great rest of your day.